Hello everyone, it's Mr. Wolf here, and I'm going to be going over problem number 2 on page 11. So if you're still a little bit not sure how to go ahead with these proportional reasoning problems with the momentum, this could be a helpful guide. Now remember, make sure you click on that QR code, watch this video. I think it's a really interesting example of treads and stopping distance, and it provides context to the problem. But let's actually look at the problem. So remember that when we're doing proportional reasoning with momentum, we're going to use this equation right here. Ft is equal to mass times change in velocity. Right? It's our two variables that are equal to the change in momentum. And when you read through this problem, when I first read through it, after I finished reading it, I was like, I don't remember a single thing that I read. So if that's how you're feeling after you read those problems, that is okay. That's how I felt. What we want to do is just take it step by step, and then we're going to use our tools of solving to kind of get things in order. So Joey and Ryan are out driving in the snow. They each slam on the brakes and skid to stop in their cars. So I know that they're coming to a stop. Their final velocity is 0 meters per second. It takes Joey 1.8 seconds to stop. So boom, I have a unit behind that number. So I know that that's an actual number. And something that I forgot to put in here is the actual unit. But an actual unit is time is 1.8 seconds is that original for Vandy. All right. And in this case, right, before I continue reading, my goal is to figure out by what factor different is the time it takes Ryan to stop compared to Joey. So where the heck did Vandy come in here? Let's change this real quick. Took Joey. All right, took Joey 1.8 seconds to stop. Our goal is to figure out by what factor does that time change for Ryan. All right. Now, if I keep on reading here, Ryan was driving twice as fast. So I'm going to say that my delta V, my change of velocity, is twice as fast. Now, you might be wondering, well, isn't that your initial velocity, Mr. Wolf? It is. But if they're both coming to a stop, all right, then that means that their final velocity is 0. So if those are the same, then their initial velocity is going to be twice as much, just as the change in velocity is going to be twice as much. All right. In a lot of these momentum problems, either your final or initial velocity is going to be 0. And if that's the case, we could use change in velocity to figure out these problems. All right. Driving twice as fast. And Ryan's car is 2/3 the mass. So I'm going to put 2/3 for the mass. And the force of friction stopping Ryan's car is going to be 2/3 the force of Joey's car. So again, I'm going to use this equation right here, and I'm going to start to plug in my factors, because if I'm looking for a factor, I could only use factors. So this 1.8 is not going to be here right now. My force is 2/3, my mass is 2/3, the change in velocity is twice as much, and my time is what I'm solving for. So the 2/3 kind of cancel out on both sides, and your time is twice as much. All right, so it took Ryan twice as long to stop compared to Joey. So then, well, what is that actual time? Well, if Joey took 1.8 seconds to stop, all right, well, then that would be 3.6 seconds. Looks like I made another error here. So wrong units. I'm going to go ahead and just fix it right here too. All right, so if I got twice as much, all right, for Ryan to stop, then we multiply that by Joey's time, 1.8 seconds, and we get that it took Ryan an actual 3 seconds to stop. Thanks for watching.